Welcome back to the Startup Show. I'm John Biggs. Today on the show, we have Justin Fiaschetti. He's the CEO and co-founder of Inversion, which is making re-entry vehicles, space re-entry vehicles. Uh, that's pretty crazy. So, are you in one right now? What's the situation?
Yeah, well, not in one right now, and at least for now, we're not focused on carrying people.
Mm-hmm.
So what we're building at Inversion is space capsules that are able to store cargo in orbit, in low Earth orbit, and then deliver it to anywhere on Earth in under an hour. This basically makes it so that you can have a new transportation system for humanity. We're using technology that's been done since the 60s, and we have our first flight coming up in October.
So let's talk about this. So what am I doing? I'm sending a box of stuff straight up in the air, and it waits to come down. Is that
That's
the
right. Yeah. So the reentry vehicles we build are also spacecraft, right? They have solar panels, they have radios to talk to it while it's in space. We load them with cargo on the ground. We put them on a rocket, could be like SpaceX's Falcon 9 rocket, for example, and then we put them into space, into low Earth orbit. And they kind of hang out there until they're needed in a lot of ways. And then when they're needed, we send the GPS coordinates up to the capsule and we say, hey, come back to this location. The vehicle will then autonomously guide itself down and land highly precisely to that location. And the mission we have happening in October, the vehicle's name is Ray. It's a subscale vehicle compared to what our main product will be. And it proves out kind of all of the technical capabilities that are needed for this product, right? For this ability to deliver medical supplies or drones or what have you. And so in October, we'll go to space. We'll stay in space only for a few weeks before we fire our rocket engine for about 8 minutes, which allows us to re-enter the atmosphere. And then we'll splash down off the coast of California, softly under parachutes.
okay? So there's also another thing you could probably put in those boxes that may not be, I don't know, Amazon packages. This sounds almost like a weapon too, right?
So this is not going to be used for weapons.
Mm-hmm.
This is very specifically around delivering like medical supplies to wounded soldiers or drones for surveillance. There are a few treaties that outlaw putting large-scale weapons in space. What this is just like the aircraft was introduced 100 years ago, or ships were introduced there before that. This is a transportation platform, right?
Mm-hmm.
And it's able to, the value of it is it has broader access to the globe faster, right? Those two attributes are kind of the evolution of transportation across human history, whether it be the horse and chariot that allowed for broader access faster on land, or ocean going ships, which allowed for broader access to the globe, and airplanes thereafter about 100 years ago. And just with all of those systems, this is a new layer for humanity of having a new transportation modality.
So the very specific thing here is it's going to come back down in a very specific place. That's your secret sauce, I suppose.
That's
Getting
right.
getting that getting that box of, I don't know, much needed water or something like that, or I don't know, medical supplies to a place that nobody can get to within an hour, which sounds pretty wild.
That's right. Yeah, exactly. When you look at any sort of transition from one transportation mode to the latest and greatest, right? The first use cases are always relatively niche that
Mm-hmm.
exploit the value of that new methodology, right? So with airplanes, it was mail, right? You needed to get mail fast places, and now airplanes are used for literally everything, and we expect that same kind of growth in the market to happen here, where you start with cargo that is needed in remote areas very quickly, and especially for national security reasons or disaster relief reasons, those I think everyone can conceptualize and it makes sense right away. But as we bring costs down, right, through reusability, through rockets becoming fully reusable, the costs start to become very close to the same increment as the difference between shipping by boat to airplanes
Mm-hmm.
as it is airplanes to space. And we expect to see a similar transition from as we did about 100 years ago.
So that sounds pretty wild. do you ever expect to be like a situation where it's like, I don't know, Sheen packs up a box of clothes and delivers it to LA in an hour?
Well, so I mean, I think a good example of this is like this is a highly elastic market,
Mm-hmm.
just broadly. If you could have a set of spare car keys in space and deliver to you anywhere you are in
Yeah, yeah,
30
yeah.
minutes, that would be
I mean,
amazing,
it
right?
might
As
hurt,
long as
but
it wasn't a
yeah,
$1 million a pop, right?
yeah.
And so as you bring costs down, you start to find a lot of those similar use cases that are beneficial. Now, are we going to be delivering DoorDash, through space? Like
Yeah, yeah.
probably not anytime
I
soon,
want to get
right?
my Chipotle in Shanghai from
Exactly,
Nebraska.
exactly. Like the terrestrial logistics for those are already well established and very useful, right? The core benefits of what we are providing is basically warehousing in space, so that you can have effectively a warehouse an hour away from every part of the world, and obvious first national security applications around saving soldiers' lives, around deploying detection equipment to understand what's happening in some part of the world, as well as disaster relief. And you can see how as you bring the cost down, your commercial markets become really exciting as well.
Hmm, that's wild. So, what are some of the challenges that you're facing with this project?
Yeah, so anything in space is always a challenge, right? Hardware, it has supply chain constraints, it has manufacturing lead times. You get one shot at your mission, right? You can't test. You can test a lot on the ground, but once you put it in space, it either works or it doesn't.
Mm-hmm.
So for this first mission we have coming up in October, we break it into three phases of flight. The in space portion is the first part, which is where we get communications with the space capsule. We point it at the sun to charge the batteries, and that lasts a few weeks. Then we have the what we call the deorbit portion, where we fire our rocket engine to basically slow the space capsule down so it falls out of orbit. That has a lot of challenges because rocket engines are fickle, and especially one that we're flying for the first time.
And is this a solid fuel, or are you guys doing anything special?
Yeah, so we're using a bipropellant system, which is a fuel and an oxidizer that combine to create thrust in our thrust chamber. Solid rocket motors kind of have all of the components of the fuel packed into effectively a solid block. But by going with this bipropellant system, we're not only able to easily control how much thrust we have, but we can also store the propellants for long durations safely. And so they're relatively common propellants.
Hmm, interesting. And you guys went through accelerators, got some investment. What happened at that point? I mean, it's kind of crazy to go in to talk to like some VC and say, "Hey, we're going to send a bunch of rockets into space, and then we're going to land a box in I don't know, on the top of Mount Everest to within
Yep.
like 2 meters, just so somebody can have a glass of champagne when they get to the top."
Yeah. So we went through Y Combinator in the summer of 21. Incredible accelerator. They have a lot of heritage in funding both space companies and just generally hardware companies, from Astranis, Relativity Space, Boom Supersonic. And we found that super useful, right? Myself and my co-founder founded this company at 20, we were 22. I was 22, he was 21. And we learned a ton from that. We then raised our seed round of $10 million coming out of it, which has allowed us to build out our team and build out this first test mission that's going up in October, which normally would take about an order of magnitude more money to
Mm-hmm.
build, but we've managed to be very capital efficient as a business. And you're right, when you go to investors who generally look at software businesses and say, "Hey, I know this hasn't happened before, but what if? What if
Yeah.
we could have global access in under an hour? What if you could store cargo without regard for sovereign borders? How does that change humanity?" Right? The aircraft made it so that we had globalization effectively, right? And it allowed cultures to intermingle and cross, and in fact resulted in quite a bit of peace throughout the world. what happens when sovereign borders, because space is international, right?
Hmm.
How does that change the world? And I always talk about how if you or I walk outside right now and you look up at the sky for a minute or two, you'll see 5 or 6 airplanes fly overhead of you. You never notice that if you're not
Hmm.
looking for it, because it's mundane, because it's common. And that's what we want for spacecraft, for space capsules reentering, where in 10, 15, 20 years from now, we're just another thing that's happening. And my goal is that eventually my grandkids will not even notice that those are a thing.
Now, is there a? I guess you'd have to do the physics to make sure that you're coming down exactly the right spot based on the rotation of the Earth, gravity, all that other good stuff. Is that the hard part, or is the hard part just getting these rockets to go up and come back down again?
Yeah. So the hard part is landing precisely. Um, Reentry vehicles have been done since the 1960s. And in fact, there's been proof that you can land very precisely. The space shuttle landed on a runway, but that
Hmm.
had massive wings. It's very expensive. Was piloted by astronauts, and so landing very precisely in high winds, in austere environments, without GPS potentially,
Mm.
that's a big challenge, and that's what we focus a lot on here. Re-entering from space is like a quasi-solved problem. SpaceX has done it, NASA does it, Russia, China, India, Japan. Um, Implementing it into a great product, that is where we focus. Right, taking technology that has existed before and merging that with a market that needs this in a very intentional product decision. That's what we spend most of our time doing at Inversion.
Hmm. Interesting. What have been your biggest challenges?
I think there's always challenges for any startup at different stages. They're totally different, right? When you first get started, like the first challenge is recruiting, right? Getting the team you need together, especially for us, because we have 20 different engineering disciplines within Inversion, right? From software to parachute design to structures design. So recruiting was an early challenge, and we've managed to solve that problem. Other challenges are always about supply chain for hardware, right? Like if a vendor doesn't deliver one of the 1,000 parts that go into the vehicle, then the vehicle doesn't fly. And so making sure you have robust supply chains that are redundant. So if someone fails, you can go to your other supplier. That's been another big focus of ours as well.
Hmm. So your goal is to make these fairly ubiquitous. It's going to be this will be fairly common over the next couple decades, I suppose.
Exactly right. Exactly right. Yeah, there'll be thousands in space storing cargo. There'll be ones re-entering around the globe, multiple times a day. It'll be as if it was just another aircraft, right? Fully integrated with, flight traffic control, and where nobody even thinks about it twice.
Yeah. So this is much different than a regular startup. So what do you have to do as a founder to essentially keep moving forward? I mean, obviously, you have to wait until October to get this thing off the ground, and the potential for catastrophe is pretty high. I mean, I don't want to bring down the party, but I mean, you're blasting a box out of space to hit the ground. Um, what are you doing to I don't know to manage that stress and manage the business the way it needs to be managed?
Yeah, absolutely. So most startups, especially in software or B2B SaaS or just general startups, have uh, very smooth growth curves, right? They're relatively you can trace one customer to another. Inversion's whole business, and just generally any space or hardware company, has large step changes of growth, right? It's a relatively binary outcome of what happens in October. Um, Customer contracts are quite large and relatively few in number, right? We're not having
Mm-hmm.
millions of customers. We're not having or hundreds of thousands. There's 10 to hundreds and maybe thousands depending on the business model. And so you have these big step changes in the company. And so morale and culture within the team has to be totally different than a normal startup, because you don't have your ARR metric to point to for employees to be excited. You don't have let's ship every single week for a rhythm and cadence for the engineering team. And so what you have to do is find meaningful major milestones on the technical side that we can do regular sprints to and regular pushes to, whether that be getting to the first test of a rocket engine or getting to a drop test where we throw the parachute out of an airplane to test it. And having that regular rhythm and cadence with a clear understanding of where you need to go is actually very motivating because there is a end goal that everybody gets to push to, right? Everyone gets to push to this one mission and this one flight. Rather than just like a generic general, like we need to optimize ad sales or we need to optimize whatever. And so I think the team can have a huge level of accomplishment from that. And then it's on myself and my co-founder to make sure that, we've structured the business in a way that allows us to reduce risk for any one-off failure, right? You want to have redundancy, you want to have multiple shots on goal because space is a complicated and challenging endeavor.
Why are people trusting you to do this?
So my background was a propulsion engineer at SpaceX and Relativity Space. Have designed rocket engines in college with my co-founder when we first met. One of the biggest things that we're really proud of at Inversion is the product and market vision we've been able to put together. That's not the easiest thing, right? Building technology is quote unquote straightforward, right? Anyone can, or a lot of people can go and design a rocket or design a rocket engine. But how do you design the correct one for what customers need? That's really challenging. And then how do you scale that production? That's another really big challenge. And so we try to come at Inversion from those two dimensions, which is being at scale for production and making sure our product matches what our customers need. And I think that's relatively unique in the industry.
Okay. So October is your first launch. When do you expect, if all goes according to plan and people start putting boxes into your hands and telling them to get out of here, when do you expect this to be like a common thing?
So we have our first launch.
I mean, common being relative, right?
Yeah. It's not, we have a bit of time to go until we're as common as like a automobile or something like that. I think you'll see before, in the next 3 to 5 years, this will become a thing that you forget to tune into the live stream of. That's how I generally measure, like, is this relatively common? Is when do people stop watching the live stream? I always used to watch SpaceX's launches and landings, back in 2016, 2017, 2018. And nowadays they're launching so often you don't even notice. And I think that's a great metric for when is it a common thing. And I think that will happen in the next 3 to 5 years.
Do you ever wish you and your buddies just made like I don't know, a better system for posting to Instagram or something like that?
It's funny. My co-founder, his name's Austin. We talk about this sometimes of like, when
Fitbit
you
for dogs.
Yeah. When we have to literally drive 6 hours to go get a part because we need it in time, round tripping 12-hour drives to make sure we get the part in time. We're like, think about how easy it would be to just do whatever.
Bootstrap, some Laravel. You got your app all ready to go. If you got to scale it, you just get some AWS.
Exactly. Paul Graham talks about how there's two things that founders will say, I am never going to build an X startup again. And X is either the music, because the music industry is a mafia, or hardware, because it's fundamentally hard. But here's the thing I always talk about is everybody remembers the first time that they held an iPhone for the first time. Right. It was a magical experience. It introduced an entire new wave, a new generation of what is possible. Hardware has the ability to inspire and change the globe. Nobody remembers the first time they used Jira or Confluence or Notion. Yes, those are productive, but those are not remembered. Those don't leave a legacy. Those don't change how humans see themselves and how society is structured. This has that opportunity to do that. And if I'm going to dedicate, 19 hours a day to something, I want it to be something that in, you know, 50 years, I can look back on and say, even if I did or didn't make any money or anything like that,
Hmm.
was this worth it? Was this worth dedicating my life to? And if we can make it so that you can deliver cargo anywhere on earth in under an hour, I think that's worth it.
All right. It's pretty wild. All right. Justin, thank you for joining us. This has been enlightening.
I appreciate it. Yeah, thank you for having me.
All right. This has been the Startup Show. I'm John Biggs. We'll see you next time.